Alright, so let's move on to finding the rule of a sine function. And for this, we're going to be using an example as we go through the 7 steps for finding the rule. So the first thing that we need to do is we need to find the halfway between the maximum and the minimum. So if you see this type of a graph, first off, you know that it's a sinusoidal function because you're increasing, decreasing. You have this regular recurring pattern that follows a sine wave or a cosine wave for that matter. And let's find the top, which is our maximum, which would be 4, and our minimum, which is at the bottom, -2. I know that halfway needs to be at 4 plus -2 divided by 2. So that would give me an answer of 1. So I draw a horizontal line at y is equal to 1. This tells you what your halfway is. This is going to help you out figuring out all your other parameters. So we move on to step 2, and for step 2, I want you to draw a box. So that box that we were using to graph, we're now going to use it to find the rule. So choose your starting point. In this case, you can choose any point which is on that halfway line. So I can choose 0, 1, 1, 1, 2, 1, 3, 1. Any of these points that is on the halfway line, I can choose. And we call these the inflection points on the red line or on the horizontal line. So in my case, I decided to use 0 and 1 just because it's easier. And there would be my box. Now, how do I know how long my box is? Well, we said in the previous video that your box represents the length of your period. So just find the whole amount that it takes before your sinusoidal function starts to repeat. And that would be 2 in this case. So at 2, it would start repeating. And your height in this case from that halfway line would be 3 and 3. So that's going to help us out now because we need to determine if a times b is going to be greater than 0 or if a times b is less than 0. And we said if you're decreasing, if you're going down, then you obviously know that your a times b is less than 0. So in this case, our a times b is less than 0. So let's find our h and k. Well, we've done this already because we chose our starting point previously. So our h in this case is 0, our k is equal to 1. And now if we were to find the absolute value of a and the absolute value of b, well, for the absolute value of a, it's pretty simple. It's just your amplitude. So your amplitude in this case is 3. For the absolute value of b, we need to remember our trusty little formula, which was period is equal to 2 pi over the absolute value of b. So when you simplify and you algebraically manipulate the equation, you get the absolute value of b is equal to 2 pi divided by period. So in this case, we get 2 pi divided by 2, which gives us pi. So we now know what the absolute value of these two numbers is. However, we need to figure out what their sign is. Well, we said that a times b is going to be negative. So there's two ways of getting a times b giving us a negative answer. Either a is negative or b is negative. So you can choose either or. So whether you say 3 and negative pi or negative 3 and pi, you would be correct. So step 7, you're going to write your rule down. So either you use negative a with a positive b, or you would use positive a with negative b. Now I put parentheses here just so that we're able to differentiate between our parameters. So parameter a, parameter b, and this would be your k since we have no h because our h was 0. However, what I would like you to notice is that on our halfway line, we could have chosen any starting point. We said this already. So if I wanted to choose starting point 1, 1, well, in this case, my h is equal to 1, my k is equal to 1. And you would put a rectangle to show your next period, right? And again, you would get a period of 2. However, it would change your rule. By doing this, your a times b now would be positive because you are increasing from this starting point. So a times b would be greater than 0, and we have a new h. So step 1 remains the same. You still have to put in that halfway line. You put in that starting point. You put in that box. Your h and k is 1 and 1. Absolute value of a is 3. Your absolute value of b is pi. Again, the parameters are remaining the same. The only thing that's changing in this case is that because a times b is positive, Either both a and b are positive or both a and b are negative. So when we put our rule together, we get 3 sine of pi x minus 1 plus 1, or negative 3 sine of negative pi x minus 1 plus 1. Now aesthetically, I prefer the first one, so either both positive or just your a negative, as we saw before, just because it looks nicer. It's easier to understand. But again, you could also be given the negative, and it means the exact same thing. So, an observation that I really want everybody to pay attention to, that any given sine function can be described by many different rules. So let's do example number 2. So in example number 2, we have something special. They gave us a point. Now this point signifies something important, and we need to figure out what that is. But before that, let's go back to our steps. So step 1 said find a halfway line. So what would be halfway between 2 and negative 3? Well, 2 plus negative 3, divide that by 2, and you get negative 0.5. So we should get a halfway line right there. And then we realize the importance of that point. That point was given to us to use as a starting point. Why? Well, because it's on the line, and it's giving us the exact coordinates, just in case. Because sometimes it's very difficult to read the coordinates off of a graph directly when you have a curve, whereas a line is much easier to read. So in this case, let's move on to our next step. Let's put that box around it, and we found our period by determining when the function will repeat. Well, if I have a valley at first and then I have a mountain, I need to find the next time I have a valley again, which would be right here. So my period in this case would be pi. A times b would be less than 0 again. Your h is negative pi. Your k is negative 0.5. The absolute value of a is 2.5, and the absolute value of b in this case would be 2. And because a times b is less than 0, so either your a is negative or your b is negative. Does it matter again? No, not really. Whatever you prefer. I honestly prefer having the negative a. So, whether you give the first rule or the second rule, you would be correct. Now moving on to example number 3. Now for example number 3, this question is a trick question. So what's really important to understand here is that you won't always be given nice numbers to work with. So if I have a graph like this, again, first thing I need to do, set up my halfway line. So halfway between 4 and negative 2, I know that I'm going to be a line at y is equal to 1. So once I have this, I need to choose starting points. And I have several starting points that I can use. I can use this one, or this one, or this one, or this one. Well, here's the issue. I don't know what every grid marker signifies here. So I really need to figure that out before I can start figuring out what this point is. I know the y is going to be 1, but what's the x value here? So what I want you to do is count boxes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In other words, every 12 boxes makes a pi. So each box is 1/12 of a pi, or pi over 12. So your starting point in this case would be pi over 12 and 1, if I were to choose the first one. And from there, my period would be from when I start to when I end the cycle and I begin again. So if I had a mountain at first and then I had a valley, well, I need to find the next mountain. So how many boxes does that represent? Well, 1, 2, 3, 4, 5, 6, 7, 8. So 8 over 12 pi would give me a period. 8 times b is positive in this case. My absolute value of a is 3. And my absolute value of b ends up becoming 3 when I divide by the period. Now, since a times b is greater than 0, both of them need to be positive or both of them need to be negative. Again, aesthetically, I prefer having both of them positive. However, if you have both negative, that would also be acceptable, and it is a correct answer. So again, very important that we go back and we check. Did we do this correctly? Yes, we did. pi over 12 represent each of these boxes. Watch out for this type of a trick because it does happen fairly often with these sinusoidal functions.